Hello everyone. In the last two videos actually, I did something a little different. Instead of doing a video on math, I did a video on a puzzle and Sudoku. In fact, there's a specific type of Sudoku called um, killer Sudoku, which involves a little bit of math. In fact, regular Sudoku involves math, so it's kind of interesting. But I mentioned that I'm interested in doing other puzzle videos, and I name dropped this this particular puzzle called Yajilin, which is a pretty similar style. It doesn't have numbers, but it has some numbers, but not so much like Sudoku, nor even Killer Sudoku. And it may not seem like there's a lot of math involved, but it is pretty logic based and a lot of fun. I really, really like this puzzle, and I'm really happy to share it with you. So it's a little interesting because, as far as I know, I haven't actually checked for a while, but I have Apple devices. So when I go on iOS on the App Store, sorry, there aren't many options for Yajilin. And also the way you spell Yajilin, because it's derived from the Japanese word for the name of the game or the puzzle, it may kind of vary. So if you Google it, I'm sure you'll just type in Yajilin puzzle. And in fact, I'll have more or less correct spelling on the title of this video. But anyways, this is the one I have. This is by an app company called Two Cats. It's okay. There's quite a few options here, and there's a lot of different variety. So I'm going to start off by showing you the rules, and then we'll go on to a harder puzzle. So let's see. So here I'm going to start with a 7 by 7, and there are. I'm going to select game 3. So I already went through 1 and 2, and you'll see there's a lot of numbers with arrows. And the way it works, and actually it tries to describe a rule set. So if you go back to the main homepage, there's a how-to, and it kind of describes how to play the game. But basically, everything right now is blank. And if I touch a block, it'll be black, and if I touch it again, it's white, and if I touch it again after that, it goes blank again. So you basically are tasked with tiling every blank tile with white or black. Okay. Now, if you are to mark any tile, like even the one with a number as black, it's completely blocked off. So in fact, what you're really kind of saying is that hint is true or false. So if it's white, it's true. If it's black, it's false. So every clue here is true or false. And what each clue means is in that direction of the arrow, there are that many black tiles. So if this 2 is true, there'd be 2 black tiles somewhere in that direction. That's what that means. Okay. And if the clue 0 is true, it means there are no black tiles in that direction. So these should all be white if that was true. Okay. Another key rule is that any black tile cannot be orthogonally connected to any other black tile. What that means is that you cannot have something like this. So automatically when you have a black tile, you have 4 known white tiles surrounding it. You could have black tiles connected like this, that's fine. But what is also not allowed, and this is basically the last rule, is that you cannot have a white completely surrounded by black tiles like this. So that is not allowed. So that white in the middle, well, that scenario can't be allowed. So one of those black tiles must be white, basically, in order for that to be valid. And that includes something in the corner. So like this is not allowed because that white tile is blocked by black tiles. Okay, so that's it. With those rules, we're ready to go, and I'll reset. Now this save and reset feature is actually kind of useful when you get really, really involved with the advanced puzzle. So we'll see if I actually use that, but I'm going to try not to use it. It's a kind of way to guess and check different scenarios. And it's a really, like, you'll see advanced techniques used there with that. I'm going to start off one that's pointed at a wall. So like, for example, this one can't be true because there's no space for me to put blacks in that direction. So these automatically are false. Anything else? So this 0 could be true because technically there are 0 black tiles in that direction. So it could be true, but we don't know if it is. Which sounds strange because it seems true, like it is true, but it's possible that it could be blocked off. Now I said that white and black means basically true or false, but it could also just mean that it is blocked basically. So we don't know actually, which I know sounds strange, but it kind of gives you more mystery to it. So anyways, and again, we automatically know that these 3 here and these 3 here are white because of that rule involving no blacks next to each other orthogonally. Okay, and now it becomes a little less obvious what's going on. So you have to do some counting. So this 2 is notable. If this 2 is true, there have to be 2 blacks in that direction, but there's only one spot to put a black. So in fact, this 2 cannot be true. So it's false, making those true. Now that 1 is true, so there's a black somewhere in those 4 to the right, but we don't know which one it is. And that 2 below it, right here, must also be false, because if it was true, it would only point to 1 in that direction. Cool. And this 2 right here cannot be true for similar reasons, because if it was true, there would be only one black tile that it points to. So it must also be black, making these white. And we're just going to play it like basically seeing which clue is false. So clearly that 3 must be false. If it was true, then there's only 2 blacks that you can create there, so that has to be false, making that white. Okay, now what? Okay, look at the block that the 1 is right next to in the middle. That cannot be false. If it was false, or it cannot be black, because if it was black, then you'd have a bordered off area, so that must be white. So that's kind of interesting to note. I'm using that rule there. Okay, 4 cannot be true in the top left corner. And the reason why it can't be true is because there's not enough space. I mean, you see I have a total of, well, I have 1 black block in that direction. I have 3 blanks. So I could put 4 black ones. But again, those 2 over there, you can't have a situation like that. They can't be next to each other. So they must be separated by at least a white, at least 1 white. So in fact, that's false. That blank there, I don't know if that's going to be true or false. So we'll kind of leave that. That's still to be seen. We know this 2 is true, and the only way we can put 2 2s and 3 blanks is like this. 2 black tiles and 3 blanks is like that. Separated by 1 white. This must be white, and if that 1 is true, right, then either this is black or the one above it is black. And this can't be black because you border off a few areas actually. So that's white, this is black, and we're almost done. That has to be white because I would border off that 2. That 2 on the right here, let me point to it here with my mouse. So this 2 could be true actually. I'm going to use some logic here because if it was true, I'm going to do a what if. So if it was true, then this would have to be black. And I guess that could, yeah, this could not be false because that would border off an area. So that would have to be true. So I don't see any contradictions there actually. But if it was false, then these would both be true. And that 1 right there, this one, would have to point to this black, which borders off this 1. So that's not right. It doesn't sound right at all. So in fact, this has to be true, or it has to be false. Sorry. No, I'm sorry. It has to be true. See, I'm getting confused a little bit. It has to be true, because if it was false, again, you'd have this scenario, and we can't have that because it's bordering off the corner. So that must be true. I know that sounds kind of confusing, but you'll have to, again, do the trial and error thing. But so that must be true, making this false, making that white, and this cannot be black. It has to be white because it would border off this little cluster right here. Okay. All right, so we're almost done with the puzzle. Now, one of these 2 is black because of the 1 clue, so we're not sure which one yet. So that's still to be seen. Okay, this is an interesting bit of logic. So if this 2 is false, this would have to be white. And if that 2 was true, this would still have to be white, because if it was black, then you'd have 3. It would falsify the clue, right? You have 3 blacks, not 2. The clue says 2. So in fact, no matter what, if that 2 clue is true or false, this has to be white, making this black. So that's interesting. What else? Okay. So the 1 clue in the bottom left, or bottom right, means one of these 3 would have to be black. This cannot be black. If it was black, that would be true, and that's false, because 0 would point to 0 blacks, not just 1. So in fact, this has to be white. Now the 0 could be black, or it could be white. Those are both valid. I don't see any issues there. Now it's interesting because if this was black, then now it would have to be white, and that's okay. But if this was white, then this would have to be black, and that's also okay. So I'm not sure. Well, at least we know this one is, maybe that's the hint there, is that one clue finishes this blank tile off. And now there's some bordering going on here. Yeah, so now because of that one we just completed, if this was black, it would border off this cluster here, this little like big corner here. So in fact, that has to be white, making this black. And yeah, if this was black, then that would also, yeah, see, black cells divide a white cell, so that would be false, so that has to be white. And congratulations, we completed it. So now I want to do something more advanced. That was actually pretty intermediate. I wouldn't call that super beginner, but yeah, we did a little bit of a what if scenario there, so that's a pretty kind of advanced strategy. So let's tap to go back and let's see. I'm going to try 12 by 12. Let's make it interesting. So I was obviously in the middle of this one. So yeah, I have no idea how long this may take a while. So let's reset. Ugh, already felt bad doing that. But anyways, let's do it. So again, I'm going to start off with the ones that point at walls. So right there, that's false. I don't see anything else that points at a wall. Now we have things that point at walls that are not too far, like this one. But one is kind of too small. If it was like a 2, that would be clearly false because there's not enough space for a 2. So I'm going to look around the border here. Like this 2 right here, look at that. You see that? That 2. That can't be true. There's not enough space. Not enough spaces to have two black tiles there. So we're getting a lot of terrain pretty quickly. Oh, this 3, look at this. This 3 cannot be true. If it was, then you'd have 2 blacks next to each other like that. So that's false. Okay, this 2 is true somehow, but yeah, I'm not sure. Like, yeah, so that's interesting because I guess, man, it's a little hard to explain, but it has to be the zeros. The zeros have to be blocked off. Or I guess it could be like this. Yeah, that's interesting. It could be like that, and then that 1 0 could be true. But if this was true, that doesn't make any sense, right? Because the 2 clue says there are 2 blocks in that area, but if the 0 clue is after that, then it kind of falsifies the 2 clue, right? Because then there are 0 black tiles in that area. So in fact, that has to be false. And in fact, yeah, it could be one of these 2 that has to be black. I'm not sure which one. If that one was, then that would be okay. And if that one was, then that would be okay as well. So I'm not sure which one of those are. But I know one of them has to be the black one. So these have to be white. So that means that 3 is true. And in that direction of the 3, past the 2, those have to be white. Because we already have 3 blacks in that direction of the arrow from the 3 clue. Very nice. So we're making decent progress here. This 3 cannot be true. There's not enough space. There's 2 right there, and then you'd have 3 like that. Or like that. It just doesn't work. It doesn't work out, so that 3 is false. That 1 could be true, or it could be false. I forget the actual logic, but there is a way you can kind of use that. Well, anyways, I'll think more about that. Big numbers are interesting, like this 6. Can this 6 be true? So I'm gonna kind of get as close as I can to the 6 right here and just count it. 1, 2, 3, 4. Yeah, so there's 5 right there. So there's no way we can. That's like the most amount you can fit, because remember they're each spaced at least one white away. So that 6 clue is false. What about 7? Can 7 be true? So let's count 1, 2, 3, 4, 5, 6. 6 at most. So in fact, any 7 must be false because that 7's pushed back as far as it can be pushed back. And this is a 12 by 12 square. So any 7 in the corner or even inside must be false right away. So that 7 up in the top left, that's false. Okay. All right. Now that 2 is actually a pretty huge clue because we already have one black and we know we have to have 2 total. So it's either here, right before the 1 clue, if the 1 clue is true, or it's here, which blocks the 1 clue. Regardless, it's one of those two, so all of these are white. Very similar to logic we had earlier on with the 3 clue on the top right. Okay, let's see what else. 5 and 4 pointing at each other. That's actually okay because there's a black tile behind the 4, so you can have 4 in front of the 4, or I guess below the 4, and then the one behind it would satisfy the black one. Would satisfy the 5 clue. So that could be true actually. I'm not liking that 2 in the bottom left corner. There's no way that's true. Not enough space. That means that 5 is true actually. We can kind of count to see how many you can have. So it's 1, 2, 3, 4, 5. That'd be 6 already. Kind of be careful when you're doing what ifs like that. You have to make sure you know and remember which ones you marked. So what this means is that either we can have 2 in these and 2 in here, or 1 in here and 3 in there. And that's how. So at least one of these 3 is black. That's how that goes. But still hard to tell. I think it's too early to get traction on that one. Okay. This 3 I don't like because it points to 3 blanks basically, so that can't be true. So this 2 is true. That means these 2 have to be. There's only space for those ones, so that those 2 have to be black, making those white, making that white. It's always good when you unveil a clue to be true as a consequence. And I think that's the whole kind of trigger effect here, which makes this puzzle really pleasant to solve. Notice this 1 cannot be true because it points to a blank, a white tile. There we go, we're making progress. This 5, I don't think there's enough space for, so we go 1, 2, 3, and that would be 4. So yeah, that 5 is for sure false. Okay. Oh, look at this. So this tile right here has to be black if it was, or it has to be white, sorry. If it was black, it would border off that 4. You can't have that. So there we go. That has to be white. And let's see. That 0 again could be true or false. We're not sure there. This 3 right here has to be false. So we're going like really, really heavy on what must not be true or what can't be true. So just kind of by looking at space, like this 4 in the middle here, 1, 2, 3. There's not enough space for that 4. There we go. This 4 as well, not enough space for, so that's clearly false. What about this 4 now? So there was room before, but now there's not. Now we have 1, 2, 3. We only have room for 2 here, even though there's 4 blocks. That's like the most it can be. I mean, you can have maybe like this scenario, but you can't fit 3 in there. Because again, they have to be at least 1 white apart. So in fact, this has to be false. The 4 clue has to be false. This 3 right here is also false, similar reasoning. This 3 here has to be false. Kind of going that way. Oh, this 3 right here has to be false. This one could be black, but then you have 2 here, and only one of those can be black. So that's false. Oh, this 1 in the middle must be false as well because it points to 2 blacks, and it would, if it was true, then that wouldn't be the case. Okay, this 0 points to a few black tiles, so that must be false. That 5 is true now, and I think there's only one way of making that, like actually making this satisfied. Because this could be black, that one, so we need 3 more. So it has to be like that. That's the only way that can be. And now we have a lot of scenarios where we want to prevent borders. So up here on the top, preventing a border, prevent a border there, and that would border off, so that can't be. That would border off, so that can't be. And I missed this to be white somehow. That would border off this piece right here, the white one on the bottom. I think we're kind of doing okay. Oh, look, so this 2 points to 3 blocks, so that must be false. That 2 can point to a few blocks, so that's okay. There's room there. Um, okay, so here's an interesting thing. This cannot be black because if it was, that would be true, and it would point to two blacks, not one black. So that was the logic I was trying to recall earlier. So basically, regardless if one is true or not, the one immediately it points to must be true. So it's interesting to think about. Um, and that still doesn't tell me if that one clue above was true or not, though. So that's the interesting thing. That three can be true. That four could possibly be true. Okay, similar thing. Well, actually, not similar. This is actually stronger because we have this one being true and it points to a black, so the other ones must be white in that direction. And now that makes this three false. You see that? Because now it points to only two black. Or that one that we just marked as white could have been black, but it's not now. So that's interesting. We have a possible border in the bottom right corner. So we don't want to border off, so that must be white. Uh, that two on the bottom right here, this could be black or white. I'm not too sure yet. I'm trying to keep my eyes open here with everything. Oh, this two, look at that. It points to a bunch of whites. Not enough space, so that must be false. Got a lot going on there. Oh, I missed somehow. This guy right next to the three must be white. And oh, this three right here points to two blacks, but a blank. That means that has to be black. This two could be true because we have space for that. Um, in fact, we don't because I just noticed this now. Now, what we started with has now been fulfilled. This three points to three blacks. We have two making this one black. That means that two I was talking about here must be false because it only points to one black. So that has to be white. Good. So one of these four is black. I don't know which one's which, so it's still hard to tell. Trying to look to see if there are any bordering issues. Let me look at this blank here in the far right. So this two has to be false because it points to three blocks. So I'm already caught up to beyond where I was at the beginning when I undid everything. So that's the good news. We still have quite a bit to do here. No progress on this 5 line. That 2 could be true or false. I mean, it could be true because obviously it's already satisfied, but it could just be blocked off, right? Oh, this 4 right here, that's, yeah, so we have 2 there, there can only be 1 here, and then we have this one. So in fact, that 2 must have been false. Can't border off that, so that must be white. One of these 2 is black, I don't know which one's which. One of these 2 is black, I don't know which one's which. Maybe there's some logic there we can use to sort that out. This 3 points to 3, so one of these 3 is black. Shoot. Wonder if we need to do a what if scenario because we have. Well, I don't see how this one can be true actually, because if it was true, then all of these here have to be white, and that 5 would not be satisfied. So that has to be false. Probably could have seen that way earlier, but I just didn't for whatever reason. And does that help us? It helps us with this because that would border off a region. See that? Bottom left there. Okay. Good, good, good. Almost there. Now this 0 isn't necessarily blocked out. I mean, it could be, but it's not obvious because there is room for 5 still. Like if those 3 were black, that would be 5 in that 5 row or 5 column, I should say. So that would be fine. And yeah, that could be the case. And in fact, this could be white, and there's room for that. There's room to make that happen. So it's a little tough to see what's what. I'm realizing these two twos here, like this 2 here and this 2 here, they point to that. That doesn't necessarily mean that it has to be like that. It could be like that and then everything else is white, right? But if it was white, then these two would have to be black. Is that allowed? Could that be the case? So the problem here is I can try to go with it. But right away I see that it's false because of this 3 here. So this 3, we know it's true. That has to be black, but that borders off a huge region in the top left. Okay. So again, I'm trying to remember what I had. I think it was something like that. So now I know you can't have this scenario because it would create a border. So it has to be like this. Those two must indeed point at that one block that I just covered. Okay. And now there's only one way this can be for the. Oh no, actually, I'm sorry. There's still a few ways we can have this for the 5 column. So all hinges upon that. Well, I'm just going to focus in on where the 0 is. So the 0 is either true or false. If it was false, we'd have that scenario. And those 2 blanks for the 5 column will be black, and then everything's satisfied. And I think that's how it should be because of these 2 3s here. So if it wasn't like that, then it would have to be like this somehow. But then already that's kind of bad because that means that the well, actually it doesn't have to be like that, does it? I was gonna say it would border off this region here, but just because this is true doesn't mean both of those are black. Only one of them may be black. Oh, that's still tough. I think I'm gonna have to finally. I tried not to, but I think I'm gonna have to finally use the save feature to show you how I can use it to my advantage. So I'm gonna save, and now there's a load option. So it will load my save basically. So I can do whatever and not really focus on remembering it and just click load and it loads back my save state. So now I'm just going to try and one of the scenarios. So let's say this was false. Then that's that. That 3 clue would have to be satisfied. So that has to be black. That can be bordered. One of these 2 here must be black. To satisfy this 5, those both must be black. And now I can't distinguish which one's which. Well, I guess I haven't really been looking at this for. So there's too many clues sometimes where you're focusing on some things but you lose track of others. And this is a fantastic example of that. So this 4 here points to 3 that has to be black, making that white, and we're done. All right. So those are the 2 problems I wanted to show you, the 2 puzzles I wanted to show you for Yajilin. A fantastic, fantastic puzzle. You should really, really all give it a try. I can't recommend it more. There's another puzzle that I'm interested in showing called Ken Ken, which is more popular than Yajilin. It's essentially killer Sudoku, but you have different operations possibly. Not just addition, but multiplication, subtraction, even division. Pretty interesting. Maybe we'll see the next time. If you like this video, please give it a like, comment, and subscribe, all that fun stuff, and I'll see you in the next video. Thanks for watching. Take care.